Welcome to our session on yet another important rule in descriptive statistics, which we call the Chebychev's theorem. We'll again look at another important theorem called the empirical rule or theorem. So now, what is Chebychev theorem or rule? What does it entail, and how do we use and apply it? So when we are discussing Chebychev's theorem, basically, we're looking at an inequality in a statistical theorem, which provides a bound of proportions that must lie within a certain number of deviations. So it's a theorem that is closely related to normal distribution, which gives us an approximation of how many or what proportion or percentage will lie between a certain number of deviations more than 1. So we start with 0, 2, 3, 4, going upwards. There's no 1, 2, 3, 4. Can even admit decimal points. So it will tell you what percentage from the can even be 1.1, 1, but not 1. So it should be greater than 1. So it shows an equality expressed as follows, where the probability is given by 1 over k squared. So where p is a probability, k is a random variable, and mu is a mean, standard deviation is a sigma. So it gives us a picture of by how much are we from the mean. The mean is in the middle. So this is the formula that we'll be using to understand Chebychev's theorem. All right, so on the other hand, we have what we call the empirical rule, or it's also called the 68. That is for 1 standard deviation, 95 for 2 standard deviations, and 9.7 for 3 standard deviation rule. So it's also another guideline that applies when we're approximating the proportions equivalent to this bell-shaped. So if we have 1 standard deviation, we approximate this area here to be 68%. This is very closely related to a normal distribution. If we have 2, so these ones will give us, this whole area will be approximately 95%. And if we have 3, this whole area here will be approximately almost 100, which is 99.7%. So this is why it's called the 68, 95, 99% rule. So it almost follows a normal distribution where 68% will fall within 1 standard deviation, 95 will fall within 2 standard deviations, at least. Then within 3 standard deviations, that is at least 99.7. So this is how the rule goes. Now, how do we apply this rule? And of what significance is it? So I'm going to take you through a mini chart table just to guide you. I hope we have our calculators there. So if we're being asked to calculate the minimum percentage observed within 3 standard deviations or 3.5 standard deviations, so we simply calculate it as follows. So like I said, Chebyshev, the formula is 1 minus 1 over k squared. So let me start with 2. If the number is 2, what is our percentage? Percentage, you can multiply this by 100 if you want. Leave it in percentage. So this is 1 minus 1 over 2 squared. So this is 1 minus 1 over what? Yes. 4. This is 1 minus 0.25. 0.75. So this is equivalent to 75%. So this is equivalent to 75%. Let's try. What if we had 2.6? What percentage is equivalent to this under Chebychev's rule? 1 minus 1 over 2.6. Okay, what are we getting? So what are we getting there? 2.6 squared, then 1 divided by 2.6 and 1 minus answer. This is 0. What? 1 over 2.6 squared. It is going to give us 0.85207, which is about 85.2%. So 3. Let's try. What do we get? 1 minus 1 over 3 squared. So this is 1 minus 1 over 9. Okay, which is approximately 8 over 9. Which is giving us what? 8 divided by 9 is at 8.88%. Okay. About 4, and so on and so forth. 1 minus 1 over 4 squared. This is 1 minus 1 over 16. This is 15 over 16, which is 0.9375. So this is 9 to what? 3.75%. Are we together? Are we following? This is for 1. So you can summarize it in your table if you want. The number of standard deviations, if it's 2.6, what percentage are we looking at? We're looking at what? 85.2%. If it's 2 itself, I should have started with a 2. If it's 2 itself, what are we getting? 75%. If it's 3, what are we getting? 8.88. If it's 4, 93.75. So these are the standard deviations we have using Chebychev's rule. Remembering the formula being as such. Any questions before I proceed? All right. So if that is clear, we are being asked here to use a theorem to calculate how many percentages about the mean we have is 3. You put 1 over 3, it's at 8.89. 3.5 is giving us 93.8. So this is how we compute this. As simple as that. So now a question will come in a little more delicate manner. So if it comes like this, we'll say, suppose we have a distribution with a mean of 300, all right? So we should understand that confidence interval is a range of the mean plus minus k standard deviation. This is using the Chebychev's rule. So we have a lower bound and upper bound. Lower bound is a smaller figure, the upper bound is a bigger figure. Okay. So hypothetically, if I told you that your mean is 10 and we are 75% within about the mean with a standard deviation of 4. So on the mean, we put the 10, the k from 75%, remember our table, we know that 75% is equivalent to 2. Then our standard deviation has been given by what? 4 already. So this will give us 10 plus minus 8. Then to get the lower bound, we subtract 10 minus 8 is 2. 10 plus 8 is 18. So this is a confidence interval that we are using. So remember, we need to master this table just come up. The 2 is coming from the percentage we're given, 75%. All right. I've showed you how to do it. If you're not given, if you don't know how to calculate the 2, you can just use this rule. To say if I'm given 75%, I know that using Chebychev's rule, I'm going to have 1 over k squared is equal to 75%. But how do I get the 2 there? We just calculate 1 over k squared is equal to 0.75. So 1 minus 0.75. Then this fraction will go here, 1 over k squared. Then we subtract this is 0.25. And here we're going to have 1 over k squared. Cross multiply. Or you swap them, the positions here. This one comes there, this one comes there. So the k squared is equal to 1 over 0.25. And we divide that, k squared is equal to what? 4. So to find the k, we square root this side. So our k is equal to 2. It takes us back to the table that we were calculating. So I urge you to master this. If you have 2, 2.6, 3, 4. What is the percentage we're looking at? 2 is equivalent to what percentage? Messi? 75%. Right? 4 is equivalent to what? 3 is equivalent to what? 2.6 is equivalent to what? This is 88.9. This is what? 93.75 and 82.2. 5.2. And 3.75. So these ones are important. They will guide you under Chebychev because they're the common ones that I usually used. All right, so we go back to our question, which we were trying to confront. In our question, we're being asked to calculate suppose the mean is 300, the standard deviation is 50,000. Determine the price range in which we are at least 75% that the houses will be what? Sold. So what is our mean? Mean is 300,000. What is our standard deviation? Standard deviation is 50,000. What is our K? From the percentage given, we know the K is 2. So how do we find the confidence interval under Chebychev's rule? Mu plus minus K standard deviation. So here we have 300 plus minus 2, and here we have a 50. What do we have? 300 plus minus 100. So we subtract there, we have a 200. We add there, we have what? 400.
So this is the interval under Chebychev rule that will be sure that the houses will be sold at least 75%. Okay. Sometimes we'll be given an interval itself. We'll say, in this regard, refer to the distribution of home sales. The same parameters, the mean is what? 300,000. The standard deviation is what? 50. We are asked to find the minimum percentage for which our range, so given us a confidence interval, our range will be between what? 150 to 450. So we know this is coming from the mean plus minus k standard deviation. So this we know is for the lower bound, where we're subtracting mean minus k will give us what? 150. And this one is for the upper bound when we add. So mean plus k will give us what? 450. When you use any of them, you get the same answer. So our mean we already know is 300. Our k we don't know. Our standard deviation is 50. And our lower bound is 150. So when we subtract, this one comes this side to subtract. This one will go this side, it will be a positive. So 300 minus 150 is 150. So if we divide both sides by 50, we're going to have our k will be what? K will be 3. So using Chebychev's rule, we're being asked the minimum percentage. So we know that 3, the minimum percentage is what? And what? It's 8.9%. But if you don't memorize that, you can still use the same Chebychev's rule. So this is 1 minus 1 over 3 squared. So here we're going to have 1 minus 1 over 9, which is 8 over 9. So they're asking for the percentage. And when you divide this, we're going to get to 0.8888, which is 88.9%. So we are at 8.9% sure that houses will sell for the range of 150 to 450. Even if you use this part of the formula, you still get the same answers. So here we have what? 300 plus k we don't have. Our standard deviation is 50. Then here we have 450. So 300, when it goes the other side, you will subtract. So this will be 450 minus what? 300. So just to give us what? 50 is equal to 150. 150 divided by 50, the k is still 3. So we still get the same answer of 88.9. All right. So I want you to help me now on this one here. What we do, refer to the distribution. The mean is 300, standard deviation is 50. What is the minimum percentage that of the houses that should sell for between 170 and 430? Anyone to lead us through? What are we given?
Given the mean to be 300,000.
Given the mean to be 300,000, correct?
The standard deviation 50,000.
Mm-hmm.
Okay. Then
Confidence interval, what is our lower bound?
it's 430, 170.
And the upper bound?
430.
Right. So
This must be equivalent to mu plus minus k. So which value is equivalent to the 170, the minus sign? Which one is equivalent to the 430, the plus sign? Can use either of them. So 170 is equal to mu is what? 300. What sign are we using? The minus. K we don't know. Our standard deviation is 50. So when the k comes here, it will be a positive. So what is 170 from 300? We get 130.
130.
And divide both sides by 50. What are we getting?
0.6.
6. So do you remember the percentage for 2.6? If you don't remember what percentage,
85.2.
5.2.
so if you don't remember, yeah. This is what? What do we get?
0.8520.
85.2%, correct. The percentage that will lie within that.
So this one, Mr. Collins, how are we converting like a 1 minus 1 over 2.6 square root? The other, I was trying to subtract the one is, was it 8 over Shan? It was, I don't know where I did it, no.
Yes, right. Calculate a step by step. 1 divided by 2.6 squared, you get the answer. Minus the answer, you get 0.82. Then multiply this by 100, you get 85.1.
What about the 3.6, which is in the question? 3.60.
3.60.
There's 3.60.
This is just the question number, 3.60.
Okay.
Okay. So with that being said, let's now look at a tutorial sheet. So we are told in this tutorial sheet to say, number 1, the following table shows the number of home runs by leaders in the category of the National League during Zambian major baseball season. So we're given the mean is how much? 37.9, standard deviation is 11. Now, when people see such information, they become confused when we have already learned everything. So verify Chebychev theorem holds true for 2 standard deviations. Verify Chebychev rule holds true for 3 standard deviations. So firstly, what are we given here? Mu. Mu is what? Mean is that 7.9. What else are we given? Standard deviation is what? 11.
11.
But 1, our k has been given as what? 2 standard deviations. Okay. So for 2 standard deviations, what's the confidence interval? Confidence interval is equal to what? Mu plus minus k sigma. So our mean here is 37.9. Our k has been given that there are 2 standard deviations of 2. And our standard deviation is 11. So this part here is 22. So the lower bound is what? That's 7.9 minus 22. So that's 7.9 plus 22. What are we getting?
negative.
15.9, the lower bound. The upper bound is what? 59 point what? 9. So the rule under Chebychev, which says that if you have 2, our k is 2, what is the percentage? What should we get? At least how many? At least what? 75%. Remember, right? For 2 standard deviations. At least. So at this point, are there any questions before I proceed? So we're given a question. The mean is the 7.9. The standard deviation is 11. So these are the ones we're given. Then we want to verify whether these ranges these numbers that will fall within the range you're going to calculate, they hold true for 2 standard deviation. Now the question is, the 2 standard deviation, what is the rule? You should find at least 75% of the proportions. How do we know that?
So,
we know that this is Chebyshev rule. If we're going to substitute 2, so this will be 1 minus 2 squared. So this will get you 0.75, which is equivalent to 75%. If I put 3, you calculate, put a 3 there. This is the 3 gave us 88.9. If you put a 4 there, 4 standard deviations is about 93.75. So this is under Chebyshev's rule. That's where the 75 is coming from. So I said you either memorize it or you calculate it literally using Chebyshev's rule. Are we together so far?
yeah, so Mr. Collins, in terms of, so the K, it means it's the 2 standard deviation.
Yes. So here, the other part, 3 standard deviations, the K is 3. Here, the K is 2. It was.
So for the first one, we are determining the range.
Yes, we want to verify whether the rule holds. We haven't yet finished calculating it. We've just calculated the range first of all. When substituting here, the K is 2. The standard deviation is at the 11 that has been given us. So the range has been given us is between 15.9 and 59.9. So we need to now see these observations that we have here are how many? 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that 13 total. So of these 30, how many are within the range of 59.9 and 15.9? So this one is out of the range. It is exceeding 59.9. This one also is out of the range. It's exceeding 59.9. This one is correct. All these are correct. And let's go down there. Which one is below 15.9? All of them are within 15.9. So all of them qualify. So in total, out of the 30, there are only 2 that are outside. So the proportion is 28 out of what? 28 out of 30. So we need to calculate this percentage, make sure that it's at least 75% and above for this theorem to be true. So when you divide 28 out of 30, we're going to get 93.33. So we can say, yes, Chebyshev is true for 2 standard deviations, because the answer, if you got anything less than that, we'll say it's a lie. So here we've manually counted how many figures are within 15.9 and 59.9. They're 28. If you calculate them manually, you'll find that they're 28 out of 30. So 93.33. Okay. So now
Mr. Collins, then so when you say at least 75%, it should be more than 75%.
Yes. 75% and above. Even if we want 75%, it still be true. And above. At least 2 people died means 2 have been found, but there could be more. Okay, let's see whether it works for 3 standard deviations. Let's prove 3 standard deviations to start with. 3 means K is what? K is 3. So we need to recalculate the range. The range will change. Where there is 2, we're going to put what? 3. So this is what we're going to do. So mu plus minus K
range. So here our K is 3. So our mean was what? It's 7.9. Our K here is what? 3. Our standard deviation is 11. So this is the information we're using. 9.9, 11, and the K is 3. Let's first calculate the range. So let's find the lower bound. So this is 37.9 plus minus 33. Right? So that's 7.9 minus 33. What are we getting? 4.9. The 7.9 plus 33. What are we getting? 70.9. So this is a range. And here let's identify the numbers that are outside this range. 4.9 and 70.9, the ones that are outside. So start with the upper bound, 70.9. So which ones are outside 70.9? Is this 64 outside 70.9? No, it qualifies this time. So we don't wrap it. About is the 73 outside 79 or within 79? Is it 79 or 70.9? 70.9, right? Do we cancel it out or we maintain it?
We cancel it.
We cancel it, yes, it's outside.
Outside.
Then on the lower bound, is there anything less than 4.9? No, all of them are within.
No.
So there's only one which is outside 4.9. So how many out of 30?
1.
We're going to say
29.
29 out of 30 qualify, right? Only one is nullified. So the percentage is 29 divided by 30. We get 0.9, so 96.67. So now the 3% here, what is the minimum? According to Chebychev's rule, we calculate it. So it's 1 minus 1 over 3. 1 minus 1 over 9. So this is 8 over 9. So 8 divided by 9 is 8.9. So this means we needed a minimum with 8%, but we found 96%. So it is true, it's within range. Okay. Any questions this far?
Now, suppose on the lower part, we have got something less than 4.
If we had,
What do we?
if we had anything less than 4, we would cancel it out.
When we'll be adding, we also have to add it. It will be now, if for example, there was 1, it will be now 28 over 30.
Yes, it will be 28 over 30, yes. Yes. Exactly. All right. So that is what you're supposed to do. All right. Let's try another question from the tutorial sheet. We're told that, hey, let's try this question here. I think I've taught everything before we go to the empirical rule. Please give me what has been given. The mean monthly mortgage paid by all homeowners is 2365 with standard deviation 340. Using Chebychev's theorem, find the percentage of homeowners that will pay between 1685 to 3045. So what are we given in this question?
So the mean has been given.
The mean is what? 2365. Standard deviation
340.
40. The confidence range 1685 to what? 3045. Okay. Should be equivalent to the confidence interval mean plus minus what? K sigma. So using
They say, Mr. Collins, this is confidence what?
the range in short.
All right.
So we're being asked to calculate using the Chebychev's rule. Part 1, find the percentage
of homeowners that will pay between this range. So 1685, 3045 would be equivalent to what? The mean is what? 2365 plus minus K. What is our K? We don't know. But our standard deviation is 340. So this one will be equivalent to the what? The negative sign. This one will be equivalent to the what? Bigger positive sign. So I like the negative sign for myself. You don't need to do both of them. So minus. So this one is equal to what? 2365 minus K 340. So when this one comes out, it will be a positive. So what do we have? 340. So when we get the difference here, 2365 minus 1685, we get 6 what? 8. 680 we divide by what? By 340, we get what? 2. So our K is 2. So can somebody memorize what percentage at 2? We've been doing this. What percentage will it be?
This is 75%, which is 0.75.
Excellent. So 75% is the percentage of homeowners that will pay within this range. All right. Are we following? Now, using Chebychev's rule, find the interval that monthly mortgage payments will be at least 84% of all homeowners. So firstly, let's understand this 74% is equivalent to what K? So we know 1 minus 1 over K squared is equal to 84%. So we need to calculate. So this one comes this side. If we haven't memorized what 84% is, because not everything is memorizable. 1 minus 0.84. .16. So here you swap these ones here. 0.16 divided by 1. We're going to get what? 6.25. So to find our K, we are going to square root 6.25. Square root that, we're going to get 2.5. So 2.5 is our K. So now we go back to our question. The question is, using this rule, what is our confidence interval? So since we have established that our K is what? 2.5. So confidence interval is given by mean plus minus K
sigma. So our mu is what? 2365. Our K is what? 2.5. Our standard deviation is what? 3/4. Are we following? So this is going to give us 2365 plus minus 850. So we subtract 2365 minus 850. This is 1515. And we add that will be 3215. So this is our range. Our confidence interval will lie between these two. So this is how you get your marks completely using Chebychev's rule.
The issue is about now converting that 84%.
Yes, that's what the issue is. So you need to have some mathematics here. So this is 84%, 0.84. When this guy comes here, you will subtract. When this guy comes there, it will be positive. Then this minus that, 0.16. You cross multiply this by that, 0.16 k squared. 1 times 1 is 1. We divide both sides by 0.16. 0.16. That's why I said mathematically, since I'm a mathematician, I just said you swap this guy comes here, and this guy goes that side, which is the same thing here. So you divide this in there, 6.25. The only way to get rid of this square is by square rooting on both sides. So the square root will cancel the 2 there. The square root is a figure which is 2.5. All right, so I will end here. And I'll give you homework just on what we've covered today. Unless there are any questions.
So this is lecture number 4 now.
Yes, please.
I think just send also the recording so that we go through before we go through the homework.
All right. Thank you so much for your time. So in the evening, we'll look at the empirical rule and probability. Thank you and have a good day.